Hello. Before I do the video, I just want to say I want to introduce myself. My name is Sudarshan, and I'm going to do a few science videos for kids, mainly for kids, but adults can watch it too. And today we're going to talk about, well, first I want to say if you've ever heard of an ancient scientist named Isaac Newton, he discovered gravity and a lot of important equations and a few laws of motion. Today we're going to talk about Newton's first law of motion. And before I explain it, I want to do an experiment and kind of explain it, but I really want to explain it once I get to the explaining part. So here my materials are a small metal cup here. I have a small metal cup. And I have a regular playing card. Well, yeah, pretty normal. I'll explain a little bit of its differences in a few minutes. But then I have a few coins here. They're not all the same size for a reason. Newton's first law, though, says that an object in motion will stay at motion unless a force acts upon it. And an object at rest will stay at rest unless a force acts upon it. And friction is a force. So we're talking about the absence of friction, and that's the difference about this card. It has less friction, which is what we want. So first, if that concept remains true, then when I flick this card, the quarter shouldn't move, and it should fall into the cup. So let's try it. And yes, it worked. So now I am up to a challenge, but it really shouldn't be a challenge with the first law of motion. I put a nickel on top of the quarter. And this time, just to test, I'm going to flick it from the longer side of the card. Now this may not work as good because here you have a little more time to flick it, I should say, and here your finger could hit the edge, so it's probably not going to work that well. I just want to flick it from the side here when it's where the part isn't really on top of the cup. So let's just see what happens. It may not work perfectly, but let's see. Well, it still goes in because when I flick it this way, the card is actually going fast this way. So when it goes this way, it's still sliding off the cup. But I'm just gonna flick it long ways, and now I'm gonna pile up 2 more coins on it. So now I have 4 coins piled up, and gonna flick it from here, and it should go in. Oopsies. Well, now that's a thing that happened on my first try, and I should point this out. And I actually did this on purpose because I wanted to show you that it will not work if you flick it from the bottom, which is what I did. Let me do it from the side just to show you. I'm going to show you what I actually did. I flicked it like this, which is why it didn't work. What I should do, I'm not going to put the coins just this time to show you how, if you end up doing this experiment at home, be sure that you flick it as much as possible in the center so that you don't knock down the cup like I just did, so that you just flick it off like that. So now if I put all the 4 coins on top, and let me just turn this way. And now, if I flick it right in the middle, yep, see, it's in the cup. And I can counter that for you. I promise I had 4, and I still have 4 in my hands. See, 1, bang, 2, 3, and 4. So let me put the coins aside for now, and that's my explanation part. First of all, I do want to point out that we call Newton's first law of motion inertia. And it is spelled like this. So, and like I said, it states that an object in motion will stay in motion unless a force acts upon it. Some people may get confused that friction is not a force. It is. And make sure you remember that. Friction is a force. So that I don't have to say friction all the time. And so yeah. And remember I said that, let me just do a recap, that Newton's first law of motion states that an object in rest will stay at rest unless a force acts upon it. And an object in motion will stay in motion unless a force acts upon it. So, anyway, I want to explain the part where an object in motion will stay in motion unless a force acts upon it. Now, there is a, I believe, Italian scientists, I'm not exactly sure, so let me just say scientists. His name was Galileo. No, it's pronounced Galileo, so let me just write it the way it's pronounced. Galileo. This is the way his name is pronounced these days. So anyway, an experiment he did was he had a ramp and he had a ball, okay? And his his ramp, he tried to do it, and he tried to imagine with very little friction. So, and what he imagined was, well, first of all, let me show what he thought this way. He knew that the ball would go like this and end up right here, okay? He wondered, though, if the ball were to be here and it was a horizontal plane, he wondered which way, how long would it go without any force acting upon it? And the answer turned out to be it would go on for infinite time. And let's call time t. So infinite time means it'll never stop unless either friction or a force possibly the other way. If we pretend that the squirter was a ball and if it moved this way, when I hit the ball like this, I send it in the opposite direction. So, and like I said, we're pretending that this was a ball, so that's why I said when I hit the ball. But, yeah. We could slide this quarter on a horizontal plane and hit it like that. Same thing would happen. But Yeah, that's basically what Newton's first law of motion is. Thanks for watching.